Okay, this is the last video from 8.3. This is expected value and our special type. Remember 8.2 we talked about the binomial random variable where you had two possible choices, one considered a success and its complement, which would be considered a failure. When we're finding the expected value based on binomial probabilities, it's a little nicer because there's a nice formula for it. Right, so remember, binomial is the case where there's two outcomes. N represents how many times you're trying something, so that's the total number of trials. P represents the probability of succeeding on those trials, whatever it is you're counting. And Q is the failure, right? 1 minus the probability of succeeding. The expected value, and it should make sense that this is the outcome. The probability of success is P. You're going to try N times. Right, so P represents the percent chance of succeeding, and so you take your percent chance of succeeding times your N tries, and that's what you would expect your average to be. It would average out to how often you expect that to happen. Alright, so the expected value, and again, this is the formula, so we don't plug it into the calculator. Right, the expected value in the binomial case is just N times P. Right, there's no distribution, there's no frequency table, there's no set of numbers, it's just N times P in the binomial case. And so the hard part about this one is recognizing it's the binomial case and remember the formula. Alright, so we're going to run through a few examples. Alright, so the first example is, suppose on a 100-question multiple choice test, each question had 5 possible responses. A student guesses on each question. What's the expected number of questions the students will answer correctly? Alright, so first of all, you have to recognize a binomial. There's only two things that can happen. Alright, they guess it right. Success or incorrect. They guess it incorrect. That's it. And there's a chance they guess it correct, and there's the chance they guess it incorrect. So I'm going to let X be the number they guess correctly. Number of tries is 100, right? They're guessing on 100 questions. Probability of success is, so there are 5 possible responses. So there's an A, B, C, D, E. One of those is the correct answer. So they have a 1 in 5 shot of getting the correct answer, which is a 20% chance. Q, we don't need Q, but just so that you know, there would be 4 wrong choices out of 5, which would be an 80% chance of getting it incorrect. Don't need it, but there's the binomial distribution. All right, we want to know the expected value. Well, the expected average in this case would be N times P. And so we would expect out of 100 tries, the probability of success is 20% chance on each question. And so 100 times, he gets 20% chance. So it would be a 100 times 20. And so we would expect, on average, this again, so suppose 1,000 people guessed on this test. Some of them would guess more than 20 questions. Some of them would guess lower than 20 questions. If we averaged out all 1,000 outcomes, it should average out to 20. Or at least be pretty darn close to 20. So remember, this is an average based on our probability. Second example, suppose a certain model car, a study indicates that there's a 5% chance the brakes will malfunction in the first year. Last year, a car dealership sold 150 cars. Right, let X be the number of cars out of the 150 sold whose brakes will malfunction in the first year. Find the expected value for a random variable X and then explain what it means. All right, so X will be the number of cars that malfunction. Probability of it malfunctioning is 0.05, so the probability it won't malfunction is 0.95. Not that you needed that, but just so that you know, it's the binomial case, right? There's a chance it'll malfunction, which is 5%. There's a chance it won't malfunction, which is 95%. So there's 2 outcomes. It'll malfunction or it won't malfunction in the first year. And so they want to know what's the expected number in that first year would they expect to have a malfunction. Basically, how many people would they expect to sue them, right? N times P, so out of 150 cars, probability they'll malfunction, so the chance they'll malfunction would be 0.05, and so on average, out of 150. Alright, So again, the half a car is okay because it's an average. If we had a whole bunch of groups of 150, so suppose there was 1,000 car dealerships in the United States. All of them sold 150 of these cars. Some of them would have less than 7 malfunction. Some of them would have more than 7 malfunction. On average, 7.5 will malfunction. So again, on average, they would expect 7.5 cars to malfunction. And so they have to know, they have to base it if they, is that average high? Do they want to do a recall? Again, that's what they would base the information on. They would also probably figure out the plus minus on this. We don't do that. That would be something you do in a statistics class. Actually, that's not sure. We will do the plus and minus on this. That's the next chapter. Section. Not chapter. Next section. Alright, a basketball player has a .785 free throw shooting average. That means 78.5% of the time he makes his free throws. X denotes the number of free throws he makes in 250 attempts. Assume shots are independent. Find the expected number of free throws he should make. So again, binomial. X counts the number of free throws made. N is he's going to try 250 times. Probability of success is .785. Probability of failure would be 0.27. Not 27. 0.225. But we don't need that. I just need my P and my N. So we would expect N times P. So we would expect out of 250 shots, he'll make 78.5 .785, right? Based on his probability. So you take your 250 times your .785, and we would expect on average again, it's a quarter there because it's an average, right? Sometimes he's going to make more than 196. Sometimes he's going to make less than 196 out of 250 attempts. If we average out all the times he shoots 250 free throws, the average would come out to 196.25 being made. All right, that's his average number made out of 250. All right, find and interpret. Like the last example. Probability of winning a game on a given try is 0.0. So you have an 8% chance of winning a game, right? 0.08. Suppose Ralph plays a game once each day for a year. There are 365 days in a year. X represents the number of times he wins. Find the expected value, interpret it. Alright, so again, there's only two things that can happen. He's going to win, 8% chance, or he's going to lose, 92% chance. Okay, X is going to count the number of times he wins. N, he's trying every day for a year, so 360 times. Probability of success is 0.08. Probability of failure would be 0.92, but again, we don't need it for this problem. So we would expect him to win on average, out of 365 tries, 8% of the time, and so 365 times our 8%, I can read that, comes out to be 29.2 wins out of 365 tries. On average, so again, on average, if he plays this many times, right, on average, we expect him to win 29.2 times out of 365 tries. Alright, again, 0.2 because this would be, suppose he does this every year for 10 years. Some years he's going to win more than 29 times. Some years he's going to win less than 29 times. On average, it should average out to 29.2 wins out of 365 days, out of a year. Alright, and so that's the expected value. And so that finishes up 8.3. So most of 8.3 you can do on the calculator with the exception of this last stuff that we did. So the only thing that you really have to memorize and remember, if it's a binomial case formula. If it's not a binomial case, you can plug it into the stats key of the calculator, but you do have to be careful. If it's a frequency table and a probability table, you need two lists, and you tell the calculator that. If it's one list, make sure you're careful, and you don't have a frequency list, make sure that part's clear, right? You don't want to put in a frequency list, otherwise you'll get the wrong answer. So, for example, when you do this one here, if you decide to do this plugging into the calculator, you'll only have list 1. And so when you go into your calculator, make sure your list 1 and make sure your frequency list is empty. Clear that out, right? Clear it out. So if you're only plugging in one list, make sure your calculator knows you're only plugging in one list and there's no frequency list, otherwise it'll give you an error. So make sure you're careful with that. Alright, so again, those are the ones you're going to practice on your own, so that finishes up 8.